let's put the complete arbitrage or statistical arbitrage opportunity from a complete quant's perspective. So it's like making a couple of trades simultaneously to get away with a risk-free profit. And this is because of the inefficiency that exists in the world markets, right? Being a statistical analyst, or in a broader spectrum, being a quant, what we exactly do is we do our part, right? We do our statistical analysis that what exactly the world is and what it should be, and because of this imbalance, we exploit this imbalance to make money out of it. Like we make bets and we get the rewards, right? And in the longer run, again, in the longer run, because it's a mean reverting phenomena, so we eventually, in the longer run, there is no long-term bias. So we capture these short span of times, these short inefficiencies that exist in the world markets, right? So we capture those inefficiency and we make the money out of it. And the whole idea of being a quant is, I mean, given any sort of a data, like we don't care where the data is coming from, and most of the people do not, and I think it's nearly impossible to do that, like to look for the exact roots of the data. And if there is anyone in the world that knows the exact roots of the data, I think he doesn't needs to be a quant or statistical analyst or to do a lots of maths, because he already knew what the trends are, right? He can easily tell you what what sort of fluctuation is going to be the next day or the next month, or maybe the next year. So that's the case. So being a quant, we don't really care about where the data is coming from, what exact the roots are. We apply the statistical hypothesis testing and we do our part. So for example, if I have a data, and if it's and I have to look, like it's a time series data, and if and let's assume it's a normally distributed data. So if any data is a normally distributed, so we parameterize it by mean and standard deviation, right? So, and stationary means that there is no trend in the mean and the standard deviation. So this is what the stationarity means, and this is the assumption embedded behind every algorithm that we implement. So we need to make sure that the data is stationary before we make any conclusion out of the data. We make any insight out of this data, right? So we just run a test, a hypothesis test. Like in this case, we probably going to get with the AD filler, the augmented Ducky filler test, and it's going to give us the p-values. We compare the p-values, whatever the benchmark is, either it's 0.05, 0.1, and if it's less than the value, it's more likely the data is stationary, and if it's greater than the 0. Greater than the benchmark, we that's where we are failed to reject the null hypothesis, and this means that the data is likely to be not stationary, and that's where we want to make it stationary. And we add the error terms, we add the moving averages, and we add the logs of the certain particular variable of interest. So this is how it all goes about. So yeah.